Here's just a nice summary of everything we've talked about so far. Exponential growth functions and exponential decay functions. They're very similar. They're always in this exponential form. A has got to be bigger than 0 for both of them. For growth functions, b has to be greater than 1. For decay functions, b is between 0 and 1. Notice domain and range, exactly the same. Intercepts, exactly the same, 1y, no x's. The end behavior is exact opposite. For growth, as x increases, y increases. As x decreases, y approaches 0. And I'm saying y instead of f of x. Remember, y and f of x are the same thing. For decay, as x increases, f of x or y approaches 0. And as x decreases, f of x or y increases. They're kind of the same, except growth you go up, decay you go down. So if we look at this example, we've got the function c equals 179 times the quantity of 1.029 raised to the t. And this function models the amount of soda, but we live in Ohio, so we know this is called pop, consumed in the world, where c is the amount consumed in billions of liters, and t is the number of years since 2000. You can never be too careful with identifying that t is the number of years since 2000. So we want to graph the function, and I just did this on a graphing calculator, so you don't have to do it, because these problems are kind of hard to graph by hand sometimes and be perfect. The important thing is, what values of c and t are meaningful in the context of this problem? Well, the only thing we really care about is where t and c are greater than 0. But since t is the number of years since 2000, we probably started in 2000. So we just want to know where t is bigger than 0. So we want to start right at this y-intercept, and we just care about this part to the right, because this models the amount of consumption since 2000. So let's not go before 2000. All of this on the left side, that would be before 2000, we don't want. We're only concerned with the part since 2000. And then we want to know how much soda was consumed in 2005. To do that, we're just going to take our formula and we're going to plug in a number for t. Now, if you're thinking you're going to plug in 2005 for t, good idea, but you're actually wrong. Because since t is the number of years since 2000, 2005 is only 5 years since 2000, so we're going to plug in 5 for t, not 2005, because it's the years since 2000. Then we just simplify this. C equals 179 times, and I'm not going to write out everything you'd get on your calculator, but it would be 1.1536, and your calculator gives you more than just this. Then when you multiply those together, we get C equals, and I'm going to round here, 206.5. But since this was a word problem, we can't end with just a number. We need to have a sentence. So we would say, in 2005, there were 206.5 billion liters of pop consumed, which is a lot of pop. But the main thing from this example is just understand that we usually are only concerned with the part where t or whatever value you have for your x-axis is positive. That's what we're really focusing on, because we usually, time can't be negative, or whatever we have for x-axis, it potentially cannot be negative. So we usually just want to know where it's greater than 0.